Uh, this is a chapter 7 test review video. In this video we're going to be covering all the materials covered by chapter 7. We did circular motion, and then we did also gravitation, which is part of circular motion, and then we did torque and simple machines. So this is what is covered in your chapter 7 test review. Okay. First things first, circular motion. In circular motion, what is circular motion? When an object is going round and round, spinning about an axis or spinning about a center. So when this thing is going round and round in a circular path, if it's going with a constant speed, the speed is the same everywhere, but because the direction is changing, it is said to be accelerating because there is a rate of change of velocity. And because there is a rate of change of velocity at every moment, and the acceleration is towards the center. So the acceleration is towards the center. So that's the first thing we did. And we came up with some expressions for acceleration. Centripetal acceleration is v square over r. V is supposed to be in meters per second. R is supposed to be in meters. And acceleration normally will be in meters per second square. Okay, so you may need to use this equation, and you may need to find acceleration or speed or radius. So for example, if I give you the speed as 20 meters per second, and if I give you the radius, this is the speed, and if I give you the radius as 5 meters, then you should be able to find out the centripetal acceleration. So centripetal acceleration is v square over r, which is 20 square over 5, and that is 400 over 5, and that is 80. 80 what? 80 meters per second square. Okay. Or on the other hand, if you are told the speed is 30 meters per second and the acceleration is 450 newtons, so what is the radius of that turn? So again, we have to use the same expression. Acceleration is equal to v square over r, and the question is asking for r, so make r the subject of the equation. So AC times r is equal to v square. So what is r equal to? R will be v square over a. So substitute now 30 square over 450. So we have radius is equal to 900 over 450, which is 2 meters. So you can be expecting radius calculation or acceleration or even speed. So if I give you acceleration as 200 meters per second square. Acceleration is 450 meters per second square. That's a pretty strong acceleration, but it's fine. Acceleration is 200 meters per second square, and if you're given the radius as 5 meters, what is the speed? So what do you need to do now? Use the same equation. AC is equal to v square over r, and the question is asking for v square, so v square is equal to a times r. Substitute v square is equal to a, which is 200, acceleration is 200, times r is 5 meters. So we end up getting 1,000. So v square turns out 1,000. So v will be square root of 1,000. Okay, square root of 1,000, which is like 3.156, something like that. So that is meters per second. So this is your answer in meters per second. Okay, so you can expect to calculate A, calculate V, calculate radius. Okay, that's the first part. And the other thing is, which way is the acceleration directed? It is always directed towards the center. So wherever it is. Suppose the object is here, then it is directed that way. Suppose it is here, then it is directed that way. If it is here, then it is directed that way. If it is here, it is directed that way. So direction is always towards the center. So keep that in mind. And the other thing is, wherever the object is, the speed and the acceleration are always at right angles to each other. So if the speed is this way, and the acceleration is perpendicular. If the speed is this way, then the acceleration is this way. If the speed is this way, then the acceleration is that way. So speed and acceleration are always perpendicular to each other. Okay. And this, what provides this acceleration is supposed to be a centripetal force. A centripetal force is needed towards the center in order to make this object go with changing velocities. Now, what provides it? In this case, suppose it's a stone tied to a string, so the tension in the string will provide the centripetal force. Now, if you're talking about a car going on a roundabout, if you think of a car going on a roundabout, so if your car is going on a roundabout, then the force, there is no string connecting to the center, but the force that is needed for the car to go around is the friction on the tires by the ground. And which way is it? It is the same way. And if you're talking about the sun and the earth going around the sun, and the earth goes around the sun, the centripetal force is provided by the gravitational force on the earth. Gravitational force on the earth, that provides the centripetal acceleration. Okay, so understand that aspect. Now, for any object that is moving, the speed of the object depends where it is. If for example, a bicycle wheel is moving, so that's a bicycle wheel, and the bicycle wheel is spinning. So which part of this wheel is spinning the fastest? Of course, the ends. So the end of the bicycle wheel will be traveling fastest. Something here is not traveling too fast because it is going only this much for one turn, whereas this will have to go all around for one turn. So the further away the object is from the center, the faster it will go. Now think of a ceiling fan. A ceiling fan, when you look at a ceiling fan, the blades of a ceiling fan, so that's a blade of a ceiling fan. Now, the tip of the blade is going to go faster, the center of the blade is going to go slower, the extreme center of the entire fan is not going to be moving, it may be spinning in its own place. So, that is another concept that you should be aware of. Okay, so in circular motion, that is basically what you need to be covered. Okay. Now let's talk about gravitation. So what is gravitation? Between any two masses. So what is the law? You must know the law by heart. The law of gravitation is any two masses attract each other with a force. Any two masses will attract each other with a force, and that force is directly proportional to the product of the masses and is inversely proportional to the square of the distance between them. So that's the distance between them. That's the distance between them. So square of the distance between them. Okay, so this is basically the Newton's law of gravitation. Again, for any two masses will attract each other with a force that is directly proportional to the product of the masses and inversely proportional to the square of the distance between their centers. So that is basically Newton's law of gravitation. And so if this is the Earth and we are right there, that is our mass, the Earth is pulling us. So Earth is big M, mass is small m. The Earth is actually pulling us downward with this force. And the force equation is F is equal to G m1 m2 over d squared. You must know how to use this equation. You must know how to use this equation. You will be given the capital G value, and suppose you're finding out the gravitational force between you and the Earth. So that'll be you and that'll be the Earth, and you have to put this number in, and then the distance between you and the Earth, that is this one, squared. And make sure all those things are properly done on the calculator, and you should be able to find out the force in newtons. D must be in meters, M1 and M2 should be in kilograms, and capital G will be provided to you. So you must know how to use this equation. Okay, so there was one full exercise that you did with help. So on the calculator, when you're putting all these things in, best way to put all these things in is using scientific notations and using the E sign. So if you want to actually put Earth's mass, so it will be 6e24. So when you put it this way, you won't have any mistakes. Or if you want to put capital G value, so or anything, distance, you have to just use this idea, and then calculations will go much better. Okay, and this force is what binds me to the Earth, and that is what we normally call as weight. Weight is the force of gravity acting on you, mass times gravity. Mass must be in kilograms, gravity. This is 9.8 on the surface of the Earth, it is 9.81. So this is mass, which is amount of matter, and this is gravity, which is the acceleration due to gravity on the Earth's surface. Now suppose you go to a higher place here, your mass will still stay the same. Wherever you go, the mass is not going to change. If you go to the moon, also the mass will stay the same. If you go to the Mars, mass will stay the same. But what changes is this G. So as you go further and further away, mass stays the same, but the G will be smaller, and so you will feel less weight. So what is weight? Weight is a gravitational force. You can get this with the help of the same equation. Now, how does F change? You can see what is happening here. If the distance is changed, F is going to be affected. And you must know how the distance changes and F are connected. Okay, so because the D is being squared, force is going to be affected accordingly. Like for instance, if the D is doubled, what happens is the new force is going to be G times M1, M2 over, this is going to get doubled. So it's going to be 2D, the whole square. So if you do this, it will end up with 4D squared. So the new force is 4 times smaller because you double the distance. The new force is 4 times smaller. What if the distance is tripled 3 times? If it is a 3 coming down here, 3 squared is 9, so you'll have a 9 in the bottom, which means this new force is going to be 9 times smaller. So check into this concept. Now if mass is doubled, then the 2 is going to appear straight here, which means the force is going to be affected by the same number of times. More concern should be given to the bottom one, because bottom one changes differently. Now what if the distance is halved? That means when instead of D, you're going to put half of D. So if you put D over 2, like G M1 M2 over D over 2 the whole square, you'll see it is G M1 M2 over D square over 4. So the new force is equal to this. Now if you take this 4, because you're dividing by a fraction, if you take this 4 and take it to the top, it'll be 4 times bigger. So this force is 4 times bigger. Alright, so the closer you go, the force becomes bigger in a square fashion. The further away you go, the force becomes smaller in the square fashion. Okay, now this is the force, the gravitational force between the sun and the Earth. So sun is pulling the earth downward. So what is making the earth go round and round is the sun's gravitational force. So sun is exerting a force on the earth, which is what makes the earth go round and round. Earth is also affected by other things around, like the moon. So when you have the earth and the moon is big enough to actually pull things on the earth with a force that is quite strong enough. So because of this pull by the moon, the only thing that actually can get affected are the fluid materials like water. So water in the ocean can really get affected because of the position of the moon. So the water will drift more and more to this side, causing the high tide. You must have heard about high tides. So high tide is when the moon is pulling the water gets collected more. So it actually is called high tide. And when the moon is away, then it becomes a low tide. So because when the water goes from here to some other place, then it becomes low tide. So high tide and low tide is caused by moon's gravity. Then the other thing you should know is the weight and weightlessness. What is weight? Weight is what I just said, mass times gravity. It's a force of gravity acting on an object. Now what is weightlessness? Weightlessness is a term that is used to indicate that there's only one force acting on the object, and that is its own weight. Weightlessness is when there is only one force acting on the object, and that is the body's weight. If any other force comes in, then it is not going to experience weightlessness. Only one force. So the earth is going to experience only one force when the sun is pulling it down. And therefore the earth is in that same situation. Whereas again, the same way, we are not going to experience weightlessness because we are touching the ground and the ground is pushing us up as well. So if this is the ground, we are standing here, the weight is pulling us down, but the ground is pushing us up. So the normal contact force here, and this is the weight, those two are exactly equal and opposite. So the net force on us is zero. When the net force is zero, that means why is the net force zero? Because there is a normal force pushing you, and that will make you feel your weight. Weightlessness is when someone is actually falling from somewhere, the only force acting on him is the weight, and that is called weightlessness. Okay, satellites and all those space stations, they experience weightlessness. Anybody inside that also will experience weightlessness. So that is one concept that you must be aware of. This is in gravitation. I'll finish this. Okay, now the other concept is torque. We learned about torque. Torque is the force times perpendicular distance from the fulcrum or the pivot or whatever. So torque is equal to force times perpendicular distance. Force must be in newtons, perpendicular distance must be in meters, then the torque is going to be in Newton meter. So the unit of torque is Newton meter, the unit of force is newtons, and don't forget that perpendicular distance is supposed to be measured in meters, not centimeters. So if you're given in centimeters, then you have to change it. So if you're told that there's a force acting, the 100 Newton force is acting about this point and this distance is 20 centimeters, then how do you find the torque? So torque is equal to force times perpendicular distance. Force is 100, perpendicular distance is, don't put 20 there, instead you change it to 0.20 meters. So it'll be 0.2, and the answer turns out 20 Newton meter. So understand how these things are done, how this equation is used. And the torque is affected by what? One is a force and the other is how far from the pivot is your force applied. So this is the arm length. So if you're opening the door, when you open the doorknob is there. So when you push the door like that, the fulcrum is there, the hinges are there. So this is the perpendicular distance we're talking about. Now, what will happen if your handle is kept in the middle? Because the D is halved, the force will be doubled. That means you need to apply double the force. And so the closer you go to the hinge, the more and more the force requirement is. So this is the concept of torque. You may be expected to find the force given these two, or you may be expected to find the perpendicular distance given these two, or you may be expected to find the torque given these two. So you should be ready for those things. All right, then the last one we did was the machines. The machine is supposed to help you with the force. So you don't need to apply a big force, but you're getting the same job done. So you cannot produce energy because of machines. You're not going to produce energy. Because if at all a machine is producing energy like a generator, there must be other form of energy that it is using. So machine cannot just produce work or energy from nothing. It's only like using that energy and helping us to do smaller amount of force. You don't have to apply too much force. You use a small force, but you're getting the same job done. And that is what a machine is supposed to be. It should have a mechanical advantage. So some of the machines that we went through in class, you must be aware of the pulley, the lever, and the wedges, and then the screw jack systems, or the levers, and I mentioned the levers already, and like that, different kinds of machines can be used. Machine is supposed to make our life easier, and which means the force. It's basically talks about the force. All right, so go through the machines that is in the textbook and get some ideas about it, what it is. You must know how some of the machines are used. You should know the examples of some of those machines. So pulleys are used in cranes. So the benefit of using more and more pulleys is that you need to apply lesser and lesser force. So connecting the pulleys in special styles, we can get the job done. Then the lever action, you can see a lot of things work with that same lever action. Garden tools used for cutting branches of trees, or nutcrackers, scissors, they're all simple kind of machines. Yeah, so this is pretty much what you have in the test, and if you're not going to make some silly blunders, you should do well in this test. Okay, so good luck with this test. Study well and make sure you're confident in these topics. These are easy topics to go over and study. All right, good luck with this exam.